Well, my dear participant, now I am going to talk about data wrangling with R. Data wrangling with dplyr. See, data wrangling with dplyr, summarizing variable, summarize, group by rows, grouping by more than one variable, mutate exist, then get a histogram of gain, arrange, sort, join. So, most of this material I have again taken from a book on tidy words, that is Introduction to Statistical Inference, Introduction Statistical Inference via Data Science. So, it is by Kim and Ismay. So, this material I have taken from Kim and Ismay's book, and these are the, the, the data wrangling objects which I have covered from the book of even case study also I have taken from the book of R for data science. So, these are the two sources I have taken. Data wrangling with dplyr. Learning dplyr will help a lot in learning SQL. The pipe operator allows us to combine multiple operations in R into a single sequential chain action. For example, library tidy words, library dplyr, library New York flight 13, x is equal to C235, log is equal to this thing. So, if we want to compute mean of log of x, it comes out 1.13, but the same command can be obtained by using the pipe. So, x, the first argument x, we start from here x and then pipe, then log and then mean. See, x, then log, then mean. So, this way we can make use of piping and we can get the same result, 1.133, here 1.133. So, this is the sequence of commands. See, work just like, see, pipe commands works just like plus in ggplot2. There in ggplot2 we were having plus plus GOM plus GOM box plot or like that. So, here instead of plus we will use this pipe operator. Alaska flights, filter carrier is equal to AS, and C, Portland flights, it will filter all those carriers which are going to Alaska, and this is the Alaska flights object. Then Portland flights, filter destination is equal to, see, these rows destination is equal to PDX, they will be, we can view them. So, I would like to just open, the source file and then I will go into the details. Data wrangling with dplyr. Just I am going to install the packages first, because these packages need to be installed. So, it is better that you should install. Now, library, so here after we are running control x, then log of x, then mean log of x, it is 1.13, and same action we can make use of the pipe. So, pipe x, then pipe log and then mean. So, what it works? It works on x object, first it selects x object and then it works on log of these x and then it computes mean. So, both are giving the same result. Then see, this pipe operator works just like plus in ggplot2. Alaska flights, See here, Alaska flight is a new object and we are having filter carrier is equal to Alaska. So when we run this command, we are having Alaska flights. We can view the data Alaska flights. See, if you go into the column of carrier, it is having only AS. It is having only AS because it has selected only those rows which are those flights which are going to Alaska. So this is we can check here from filter carrier is equal to Alaska. So Alaska flights we will close, and then we are having Portland flights. From flights data we are extracting those rows which goes to Portland. So Portland flights. Now control 2, it is view Portland flights. So again, if you go into the carriers, it is destination. If you go to the destination, DEST, destination, it in the destination, yes, DEST, destination PDX only. So it is because of destination is equal to PDX. So it has only selected, filtered those rows which are going to destination PDX. So this way we can verify our commands. Now filtering many airports. Many airports object has been created. From flights data, it is filtered destination is equal to SEA or destination is equal to SFO or destination is equal to PDX or destination is equal to BTV or destination is equal to BDL. So all these options are given, and see, we can look into view many airports. So here destination is equal to only these destinations has been selected, and it is running around 21,400 some rows. Destination, dest C, either SEA or SFO or PDX. So only these things will be, only these rows will be selected. So a simple way using .in. So instead of using these operators vertical bar many times, we can have flights filter destination %in. So destination %in. So it will select all these columns. It will select all these rows belonging to destination, belonging to SEA, SFO. So it is a better command than this one. It is a shorter command. So again it gives the same result. it gives the same result. It gives the same result. So these two commands, many airports, they can be run in different ways, different manners. So we are closing this and then summarizing the variables. So first I would like to go into, so these commands we have already run and we have already seen all these commands. Summarizing variables, the function is summarize. Summarizing variables, the function is summarize. Summary temperature is equal to weather. So from weather we are using the summarize pipe. That means we have selected this weather and then we are using the pipe summarize. Mean is equal to mean temperature, standard deviation is equal to SD temperature. So here it gives NAs because we have not removed, there are some missing observations in temperature. So unless and until we will remove those observations, it will not give you the result. So when we are giving temp, see na.rm, additional argument na.rm. Here additional argument na.rm was not there. So na.rm is equal to true, and that's why it was not removing NAs, and that's why it is giving NAs, mean NA, standard deviation NA. But when we will add this na.rm is equal to true, it will remove first NAs, missing observations, and then it will compute. So it is giving the result. It is giving the result. It is just I would like to explain these things by a command. Say for example, x is equal to C 2, 4, 3, 5. So if we will compute mean of x, we get mean. But if we add NA, if we are adding somewhere NA, say for example here NA, one observation is missing, and then we want to compute mean XNA. It is showing NA. So what we have to do? We have to give NA.rm, that is remove NA, is equal to true. So it will remove NA first and then it will compute the mean. So this gives the mean of the observations of 2, 1 and 5. 2, 1 and 5. 2, 1 and 5. It is mean of 2, 1 and 5. 2 plus 1 plus 5 divided by 3. So it is 2.66. So it is the job of NA.rm. So that works there in dplyrs also. dplyr is a very powerful package and it is the part of tidyverse dplyr. So here 55.3 and standard deviation is 17.8 and this is the temperatures. Then group by rows, summary, monthly temperature, weather, and then we are using group by months, and then summarize mean is equal to mean temperature, na.rm is equal to true, standard deviation is equal to SD, temperature, na.rm is equal to true, then month, summary, monthly temperature. So it will have 12 rows, summary, monthly, 12 rows. So this is the January's temperature, mean temperature, and this is standard deviation. This is the February's temperature, mean temperature, and this is SD. Similarly, this one is December's temperature, mean temperature, and this is the SD. So this way we can get these results, and then we shall talk about library ggplot2 and glimpses of diamonds. Diamonds have, this is the data object which is available with The ggplot2, it has 53,940 rows and 10 columns, and they are caret, cut, color, clarity, depth, table, price, x, y, z. So here if we go into, say for example, require ggplot2 and then help diamonds, data diamonds, data object diamonds. See, diamond data object in ggplot2, it is in ggplot2 package. Prices of over 50,000 round cut diamonds. Description: a data set containing the prices and other attributes of almost 54,000 data sets. The variables are as follows. Actually, why I am explaining these data sets and why I am talking about these data sets? Fisher, the father of statistics, he says that unless and until you cannot escape from the responsibility of understanding a data which you are analyzing or which you are recommending. So it is understanding of the data. So by making use of help, we have the brief description of the data, then we go into the graphics, we go into exploratory data analysis. So this is all to understand the data. So that's why I always, whenever we introduce a data, I always talk about. So this is the data set which is available with ggplot2 package, and this is the description. Format: a data frame with 53,940 rows and 10 variables. Price in US dollars, this range. Carat, weight of the diamond between this to this range. Cut, quality of the cut, fair, good, very good, premium, ideal. And then color, diamond color from D best to J worst. Then clarity, a measurement of how clear the diamond is. Say for example, I1 worst, S112, S13, IF best. So these are the clarity. X is equal to length in millimeter, Y is equal to width in millimeter, Z is equal to depth in millimeter. So depth is equal to total depth Z divided by this. So this is the formula for computing depth. Then table. So this is all the details about the data diamond. Now I am going to talk about diamond data here. Diamond. So this is the glimpse of diamonds. Library ggplot2 glimpse of diamonds. So we are having the glimpse. Now diamond, then we are using the pipe. Group by cut. Group by cut. So it is grouping by cut. Group by cut. So it has arranged by cut. And then summarize by cut. Diamonds, group by cut, and then it is summarizing average price is equal to mean price. It is, so it is, first it is grouping by cut. So there are 5 levels of cut: fair, good, very good, premium and ideal. And here it is the average price. Average price. So it is mean price. Average price is equal to mean price. Now ungroup. Just group by cut and then we can have ungroup. So it will ungroup the whole. It is again 53,940. So it will be the effect of ungroup. Count rows. So by origin is equal to flights by origin. See, for example, if we want to have the counts of how many flights were made from one origin, from FWR from JF Kennedy and Lagua. So how many flights were made? So for that, first by origin is equal to flights, and then group by origin, and then what we are doing? We are using again pipe. Summarize count is equal to n. So it will give the count of each origin and by origin. Say for example, EWR has 1,20,836 flights, whereas John F. Kennedy, it is 1,11,279. Elgua 1,04,662. Now we can do these things, these commands by actually summarizing by cut. So it is giving summary by cut, and then ungroup, and then by origin. See by origin, and we can view by origin. So this is the table which we have generated, flights by origin. Then grouping by more than one variable. Here it was group by only one variable, and that was origin. But here we are organizing the two-way table, origin as well as month. So by origin monthly flights, group by origin and months. So it will make the combination of. So how many levels of origin is there? There are 3 levels of origin, and there are 12 months. So it will have 12 into 3, 36 rows, and then for each combination it is giving count and then origin monthly. So when we run this command, see, this is the 36 rows. So we can view the data by underscore origin monthly. See, these are the origin and months. EWR, the first month the count is this. For the second month count is this. Similarly, John F. Kennedy, see, the first month is this count, second month is this. Similarly, Lagua, so it has 36 rows and 3 columns. One column is origin, second column is month. So it is the combination of origin and month, and here it is the count. So this way we can have this origin by month. See, now in my next talk I will talk about mutating existing variables. So that will be in the tomorrow's lecture. That will be in my next lecture. So that's all for today's.